Welcome once again to our ITS World Congress webinar series. Today we have for you our third webinar, which is our final webinar in a series that we've put together to give you an idea of some of the themes and the topics and some of the speakers and delegates that you can meet at the Congress this September. Before we actually get into the webinar, I'd just like to give you a brief reminder of what we're talking about. Our Congress is going to take place in Dubai from the 16th to the 20th of September. The venue is the huge Dubai World Trade Center, which is about 20,000 square meters and quite an impressive venue with demonstrations, exhibitions, special interest sessions, and technical sessions all under one roof. So, as I said, we're expecting almost 15,000 international participants and over 500 exhibitors. Most of the exhibition space has been sold out, but if you're still interested, do get in touch with our sales team. The information is all on our website, and you'll have a possibility to take part there. We also have some Congress packages, partner packages that will allow you, for instance, to find ways to express thought leadership, generate leads for you, give your brands exposure, and of course, help in community building and networking. One final reminder, very important one, the early bird registration period ends on the 15th of July. So if you have not already registered, please do that as soon as possible. Some house rules worth repeating. All attendees are in listen-only mode, you're muted, but you have the chance to ask questions through the Q&A window. If you have any questions, please type them in and also say to whom you're addressing the question. And just for your information, the webinar is being recorded and there will be follow-up articles on the Airtico communication channels, LinkedIn and the website. So feel free to come and join us and there and find more information. So now, before I hand you over to my colleague, Dr. Stefan Dreher, to do the panel discussion, I just want to tell you that this topic today is on automated mobility, one of the 4 Congress topics. And the topic has been consistently one of our most popular topics in terms of submissions in response to the calls for contributions that we receive. And we have the moderator, Stefan, my colleague Stefan, who heads the CCAM department at Airtico, and he's also the leader of one of the clusters of the CCAM partnership, that is Cluster 7, which is on coordination. So he's actually best placed to lead this panel, a very diverse panel from all across the world, as you can see, impressive panel from different sectors. So without any further delay, I hand you over to Stefan, all yours.
Thank you very much, Rita, for the kind introduction, and welcome as well from my side. So I will indeed have the pleasure of guiding all of you through the rest of this webinar and the panel discussion. So before doing that, let me briefly introduce the topic and also speak about how we are addressing this at Airtico. So on the next slide, so the CCAM topic is not only an important and popular topic at the ITS World Congresses and will again be in the spotlight in Dubai, but it's also one of the main areas that Airtico is working on together with its partner. And as with all our areas, if we can go just to the previous slide quick. As with all our areas, we have a roadmap that guides us or sets the path actually for the different activities that we have at Airtico in order to reach the vision. And just briefly, I will not go into details, but the vision that we have is that by 2035, we would like to have operational CCAM services that are integrated in the current transport system, that are accepted, are inclusive, and supported by infrastructure, in order to achieve also supporting the policy goals of the European Commission in terms of decarbonization and safety. So on the next slide, so there are, I think what what we hear a lot in the many discussions we are having, at least in Europe, and also something that was highlighted a lot in the high-level dialogue that took place 2 weeks ago, organized by the Flemish presidency of the European Union, is that there's a wish from many, if not all stakeholders, to really move towards deployment. As technology has gone really very much far so at the moment, but there are many promises that CCAM can help addressing efficiency, safety, and sustainability of the transport system. But there are still many questions and challenges that are remaining. And on this slide, I just illustrated quickly the different areas that we are working on in order to address these challenges. So there is a strong need definitely to work further on coordination tools. So here we are developing and maintaining an EU-wide knowledge base in order to facilitate the sharing of best practices and lessons learned in this frame of the EU-funded FAME project. We need to work on common methodologies, common terminologies in order to make sure that we are all speaking about the same things. Another important challenge is the societal aspects. We need to increase awareness through large-scale demonstrations, but as well really actually by co-creating the solutions together with the citizens and the wider users. Infrastructure is an essential topic. We want solutions that are well supported by the infrastructure. So for that, we need to identify together with all stakeholders of the value chain the needs for high-level automation in terms of digital but physical infrastructure and also connectivity and all the different topics. And finally, regulations. So it's not related to research, but we strongly support that. We want to work together with the member states to support harmonization, facilitate the testing and the development of liability frameworks, and also provide recommendations actually for alignment in terms of legislation in order, in the end, to facilitate deployment. So without further ado, I would like to give the floor now to our distinguished speakers and panelists who joined us online today from different regions of the world to share their perspective on CCAM. So we will have with us today first Dr. Max Lemke, who is head of unit of DG Connect at the European Commission. Then we have Dr. Steve Dellenbeck, who is Vice President Research and Development at the Southwest Research Institute. And we have Ryota Shirato, who is Senior Vice President of ITS Japan. Then we have Robert Sikora, who is Director for Europe of the OMIO Group. And last but not least, we have Dr. Ismail Zodi, who is expert on future and innovative mobility at RTA in Dubai, who is our host for this Congress. So let's then start with the presentation. So I would like to start by giving the floor to Dr. Max Lemke from DG Connect, and who will speak about the European strategy towards the vehicle of the future. Max, the floor is yours.
Yeah, thank you very much, Stefan. I would like to give you a short introduction on the European strategy towards the vehicle of the future. For me, the vehicle of the future, being autonomous, is one feature, or automated and autonomous is one important feature. I know we are talking around the world here, so I would say good afternoon, good morning, good evening, wherever you are. Next slide, please. When you look at the vehicle of the future, how will it be? So it's clear, it will be electric, it will be connected, it will be autonomous, or at least automation to a higher degree, and it will be shared and servitized. And that is happening all in parallel, and that means a big disruption for industry, but also for us, because we need charging stations, we need whatever we need for that. So we see the lines of software code increasing, I would say, exponentially, and that means productivity in software engineering is a key issue. Lack of talent, lack of resources, and low productivity because we have to customize maintenance, everything. Share of electronics in total cost of a car is increasing. That does not only include hardware, but software is a high cost as well. And we see an evolution of the the electronics architectures in the car. We had a bit the situation that one component came with one electronic control unit, all provided by one supplier. Now several components are sharing the bus and the computation, and that means they go across suppliers, and that means a new role for OEMs or new actors who are coming in. Next slide. So vehicles are no more introverted. They don't only run from their own, but they are linked to their infrastructure, and autonomous driving works best if a vehicle is best connected to other vehicles, to the road infrastructure, but also to the charging infrastructure. And for that, access to data and cloud edge resources is essential. The value chains are changing with new actors and dependencies emerging. We see new partnerships, I would say, emerge and die. Yeah, we see both happening. We see new actors engaging in the sector, like, for example, the hyperscalers coming from the entertainment side, the hardware companies coming from the hardware side, and the OEMs and tiers, the suppliers, being strong on the safety critical part. We see also that vehicles, and I use this analogy, vehicles become smartphones on wheels with high safety and security requirements. So then we need the car operating system, which is, you see a lot in the press, or the software-defined vehicle platforms that connect all the digital components. And we see a new generation of hardware needed to power the autonomous vehicle of the future, which basically means the AI inference phase. And these chips in the car, they have to be low energy because they also have to be running in an electric vehicle, and they should not consume a lot of the kilometers an electric vehicle could go. They must be highly customized, they should be secure, and they must be affordable for mass products. And we are not there yet. We have these chips, but I don't think they have all these requirements. Software engineering efforts increase exponentially, lack of resources, but generative AI is a technology that could help us to increase productivity again. So there, AI may be a means to help us. Open source is gaining traction in the automotive sector. Next slide, please. And how does Europe address this vehicle of the future itself in its innovation strategy? So there we address that a bit. We address that coherently in a bigger strategy with many components that work together. So if I start, for example, at the bottom, the green part, we work in a partnership which is called the CHIPS Joint Undertaking. We work on an automotive hardware platform which is open source RISC-V based across the spectrum of computing power that you need, from low end to high end. In the CHIPS EU, we also work on a platform for the software-defined vehicle of the future ecosystem. That's what I have started about 2 years ago. We look down to the hardware and want to get a certain abstraction from hardware to make hardware exchangeable. But we also look to the application, the autonomous, the chassis, the cockpit, and the body comfort application, and look at API and the middleware framework there. And that is basically where all the digital components are connected, which makes it easier for companies to compete in that market in a fair way. And finally, we obviously have the functionalities related to the autonomous driving, which is addressed in the Connected and Automated Mobility Partnership. But also we have the aspect of electrification, the green aspects in the 2.0 partnerships, and others around. So we address that across these 3 levels, and we also look at the tools there. Now, AI is an important aspect there. AI comes up as the background, what is used in autonomous driving, so the algorithms in autonomous driving, also EV charging, virtual assistant, but autonomous driving is a key application there. AI for productivity, generative AI to support engineering, and then we have to work on the hardware side, because if we have all these AI, we also have to power it. We need the computing for it. Next. And then I would say a car is, I said it's not introverted, it's connected. So Europe is investing a lot in what we call 5G transport corridors along the major roads in Europe to make 5G everywhere available, and to in future also make edge cloud resources through that 5G through those 5G corridors available. A key aspect for Europe here always is the cross-border infrastructures, because we have so many borders and we cannot address that individually. Next one. And for vehicle of the future to operate in that infrastructure, it's important to have access to all the data. So there we have a big initiative to facilitate access, pool, and share data across different infrastructures, but also across member states in the transport and mobility sector. We have several projects running there who try to really build on what is existing and link that together. So we provide the governance framework, we look at the technology that is needed, we work towards greener and more efficient mobility and transport systems, and in particular, look at the aspect of mobility. Last slide. And having said all that, what is innovation and research without regulation? So there is the other aspect that comes in. This has to be accompanied. This has to go hand in hand. That is important, and fast enough. So we have regular updates of the type approval frameworks according to the EU General Safety Regulation, which sets the legal framework. And the technical rules there ensure that vehicles are safe and technology is mature for being adopted. So there's always a bit the balance, regulation, innovation, and we have to find a good compromise to also have safe and secure vehicles, but at the same time allow innovation to happen and not prevent innovation through early or through too strong regulation. So we see level 2 and level 3 emerging already, and we see that some of it is allowed. It basically shows from 2 to 3 shows a shift of responsibility in a way, if I simplify it, from the driver to the manufacturer. So that's a major thing that happens there. When we go further, this comes even more. And I would say at the end, as a final word, we always have the European culture that we see in these new innovations. Safety first. We want to avoid problems like that happened at Boeing, where a safety first company became a shareholder first company, and with some repercussions. That's at least the interpretation that you read in the press very often. And I think we have to be very clear that safety and security on the shift towards the automated vehicle is first. So thank you very much for giving me this plenary to have this overview.
Thank you, Max, for this very insightful presentation. I think you highlighted this the disruptive shift indeed towards the software-defined but also not introverted vehicle of the future. And I think that perfectly introduces actually the scope of our webinar, which is about all the different components that are part and that needs to be considered actually to enable a CCAM. So you mentioned the aspects indeed, very important connectivity, data access, the changing value chain in the automotive sector, and also the aspects now on the regulations, which are extremely important. And I think these challenges that you mentioned really set a strong foundation as well for our next presentation. So as we will move now to another region, so the US, and where we will delve into more the implications and challenges related to some of these technologies, with Dr. Steven Dellenbach from the Southwest Research Institute. The floor is yours, Steven.
Well, thank you very much. Max outlined a wide number of topics and described a very ambitious plan with lots of great opportunity moving forward. I want to focus down somewhat on how AI applies to CCAM. And some of these type of things are probably obvious to some of the listeners, but I want to also talk about some of the potential challenges or problems that are out there. Within infrastructure, in particular, vulnerable road user is a major problem. How do we reliably identify pedestrians, cyclists, scooters, motorcycles, etc.? AI is a good use for that type. ADAS systems, again, probably most people are familiar with even having their personal vehicles having ADAS systems or driving in vehicles. These correspond to the SAE level 1 and 2. These are systems that are designed to assist the driver. Again, there's a fair amount of AI in these type of systems because, as you probably know, AI is a pattern matching. You teach a system what you're looking for, and then you program in a behavior in response to what your system identified that can occur. As you move into full automated driving, SAE levels 3 through 5, this becomes much more of a challenging problem because the long game in advanced SAE levels is to not have a driver in the vehicle. So you have to have a computer system that Max very correctly defined is chips that take a lot of power and a lot of computing capability. sitting in the car and fully taking the function of what a human being can do. That's a difficult task to achieve. Comment I want to make here is Max had a graphic that's well known and well published that current cars have about 100 million lines of code, and people are projecting up to 1 billion lines of software by 2030. If you start considering the magnitude of writing that much software for each company that's doing automated driving systems, there's some potential both challenges from technically, can you write that much code, to probably equally important is how can you guarantee or assure that that software is actually safe. As a reference point, the average fighter aircraft, if you think of your country's most advanced aircraft in the military, they probably have around 10 million lines of code, maybe 15 million lines of code. So you're talking about systems that are obviously aircraft have a tremendous number of advanced systems. You're talking about vehicles that have 10 to 1,000 times more software than a single aircraft. Next slide, please. Within the AI field, one of the things I try to tamp down a little bit is that there is a lot of hype on AI. AI's been around for a long time. It's not new. Yes, some of the techniques that we're using are new on here, and this graphic from NVIDIA does a good job describing that, it's about a 75-year-old technology. What happened about 15 years ago is that the hardware technology evolved where we could start doing machine learning and deep learning type applications in a fairly rapid mode. We could gather many, many different images. We could put them together, build up a neural network, and then we can make it execute in fast enough time to be able to provide real-time performance. Generative AI, frankly, is a outgrowth in the last couple years, and we're going to talk a little bit about some of the challenges with generative AI moving forward, but primarily it's been hardware. Something else on the horizon, if you haven't read about yet, I encourage you to go out and do some research on something called spiking neural networks, because one of the challenges of AI systems currently is they pretty much only know what you teach them. These are learning systems, and so you teach them, they're not making a lot of intuitive decisions, and they're not creating new scenarios themselves. And spiking neural networks is based on something called neuromorphic computing, and this is where we are going to start emulating the brain synapses within these artificial intelligence systems, so we will truly have systems that are much similar to a human brain. Next slide. One of the things I want to throw out there is I don't want to downplay the amount of success we've had in automated systems. There's a large number of companies out there. You've got companies like Waymo, Cruise, Aurora, Omeo. I mean, the list can go on of people that have developed highway speed trucks, shuttles, cars, robo-taxis, etc. But one of the things that we need to really step back as an industry and probably slow down some of the hype about it to our end users, the public, is a lot of those only work in certain scenarios. There are still tremendous research problems out in the area of both either unusual road conditions or bad weather. For example, Aurora, who's doing automated trucking along a corridor between the cities of Houston and Dallas in the state of Texas, will not operate under medium to heavy rain. They simply shut down their fleet operations. So if you start considering some of the pictures on the left where you have lots of moisture on the roadway, more importantly, you have snow and ice on the roadway, their systems won't work. And the reason they don't work is that the sensors don't work. You can't, if a human being can't see through a weather condition, most of the sensors we have right now cannot. Yeah, there are some very, very expensive sensors that can see through weather, but they're not cost feasible at this point to actually put on vehicles. Some of the pictures on the right, it's very difficult when you take these systems and you pre-drive roads, you teach machine learning systems, you try to teach them about all the things that could happen. This is something that's just one example of what's called a negative obstacle. That's when there is essentially a hole or depression that's not expected. We don't typically teach our deep learning system to know about holes in the road. So these particular scenarios would all cause significant problems for most of the automated driving systems out there right now. Next slide. And so I put this up there also because I think the other part of the hype that's out there is that that automated vehicles or CCAM is going to be a crashless society. I go back to the numbers that Max put up, and they take my breath away when we're talking, well, even 100 million lines of code. I'm a practicing computer engineer for the last 45 years, who developed over 25 different automated vehicle systems, primarily off-road systems. And 100 million lines of code is staggering. It's staggering to know, does that code work? How do you test it? How do you make sure it works in all different scenarios? And if we're truly going to be getting to 500 million or a billion lines of code, we are kidding ourselves if we think that these vehicles are going to be perfect. And so part of the discussion we need to be having moving forward is, at what cost are we willing to deploy this technology? We can't sell it as simply being crashless. That's not going to be true to our traveling public. Next slide. Last thing I want to put out here is that I'm sure everybody has heard about data biases in generative AI. And this is actually a very real problem. This is some interesting data for you to look at. And what happened was an organization did a study of the data that's used to feed the generative AI systems. In other words, generative AI or neural networks, they learn by taking data in, and then you essentially rerun that data through a model, and that's how the machine will make a decision. So this is simply an example. The upper left is that they looked at their training data for a very well-known generative AI system, and this shows you what skin color they assign to different jobs. And so the systems are inherently biased because the training data itself is inherently biased. In other words, all the pictures, all the information they put in, let's pick architects in the upper left, was primarily people of white skin, very few shown with darker skin. So, and then the bottom right with the various greens is showing by gender. And you can look in there, and for example, architects, a vast majority of the training data was images of men, or it was discussions of men being in architecture. So the result is the generative AI system is going to produce pretty much similar output to what was put in. So if you have biased data going into this, you're going to get biased data coming out. So as an industry, we need to understand how to better balance this and do a better job going forward. And with that, that's my last slide, and I'll look forward to the question and answers.
Thank you, Steve. We will take the question at the end. But yeah, thanks for this very compelling overview of the importance also of the core technologies for both automated driving systems, but also you mentioned ADAS and CCAM more broadly, and also the challenges that you mentioned that still need to be addressed for sensors, for artificial intelligence, such as unusual road conditions and also societal readiness. I think I agree that this is really, really important. So we need, I think, to really consider the trade-off between the different safety, efficiency, and the benefits, but as well the challenges and the potential negative impacts of these technologies. So with our next presentation, we will now move to another region, to Japan, which has also very interesting developments and is actively moving towards deployment. So Ryota Shirato, the floor is yours. Thank you.
Okay, thank you very much, Stefan. So I'm Ryota Shirato from ITSWC Japan, and the former presenters introduces some technology part of the automated driving. So from now, I'm introducing about the some development and the deployment part of the automated driving technologies. So this slide shows the development path of automated driving. So there's two ways of development of automated. One is the they adopt very narrow areas, but they have the high level of automations. And the other part is that it's the level of automation is not so high, but the area targeting area should be more wide. So we think that the path A is fit to some logistics and mobility services like trucks and buses. And on the contrary, the path B fits to some private-owned vehicles development. So the path B is now the Japanese or the automakers are trying to develop more and more on the competitive areas. So the Japanese government and we also mainly focusing on the logistics and mobility service part. Okay, so next slide, please. Next, please. Okay, thank you. So from now, introduce two major topics that are conducted by the Japanese government. One is that the Road to the L4 project, and that is conducted by MIT and MIT. So this aims to realize the popularization of unmanned AD services. So there are four research themes in Road to the L4 project. And theme one uses a small cart and driving on the private road, and there's no other road users such as general vehicle, bicycle, pedestrians. So that is a very simple and very primitive situation of automated driving. And theme two is the support for area expansion that also drive on the exclusive road, but there's some intersections crossing with the public roads. So there are some special treatment with the infrastructures to drive through the driving areas. Okay, and the theme three is the sorry, I'll go back to the front. Yeah. Theme three is the practical application on expressway. So providing merging support and information ahead, remote monitoring, and the priority lane for automated driving. There's especially planned to testing in the expressway in 2025. And theme four is the aims to establish the autonomous driving buses services in mixed traffic environment. So that they need special treatment so that they're using data from the road infrastructures. So in the theme four, they're trying to make some combination system between the cars and the infrastructures. Okay, next please. Yes, the second topic is the MIT just launched the initiatives related to the initial investment support in for all prefectures. So from the May 1st, the year-round operations and public growth have been implemented at the 16 locations through subsidized project. So the fiscal years by the end of by next March, the total of 99 projects will be adopted across all prefectures. And they aims to have the adopt the 99 project by the end of next March. So their all plans are automated driving on the general roads will be planned and operated in approximately 100 locations in 2024, and year-round operation will be implemented in all prefectures in 2025. And through this project, the government will promote the social implementation and commercialization of automated driving nationwide. Yeah. So next, please. So they're using mainly three types of vehicles. One is the small EV buses, and the second is the using small carts like the Road to the L4 Team 1. And also there's the using the vehicles without steering wheel, such as, the Navier almost, or the Amica, something like that. Yeah. So in 2024, at the moment, the small EV buses, they adopted 33 projects adopted. And the small cars, there are 7 projects. And using a special vehicles, there are 28 projects adopted at the moment. So at the moment, there are selected almost 70 projects at the moment. But by the end of this fiscal years, they're up to 99. Yeah. Okay, so next, please. So this is just a summarization of the pros and cons of AD field tests in Japan. So focusing on the logistics and mobility services, the vehicles, there are various type of vehicles are tested, but most of the vehicles are made in foreign countries, so that we wish to have the cars made in Japan. And for the connected, in Japan, we already have the 76 MHz band for ITS has already been installed. So the cooperation with the traffic lights and railroad crossing, those kind of systems are already tested in any test fields. So now, so at the moment, so we're discussing about the using the 5.9 GHz band, but it's just the start. The implementations, the Japanese government policy has the implementing edge services. It was 50 sites by 2025 and over 100 by 2027. But at the moment, most of the field tests are still level 2, so they're expected to expand to level 4. But still, we had, this is my personal opinion, but is still achievable, the government policy. Yeah. Okay, so this is the last of my presentation. Thank you very much.
Fantastic. Thank you very much, Shirato-san, for this good overview of the strides that Japan is making in automated driving. So including these deployment parts, government initiatives, and also this impressive amount of projects and demonstrations that you have. I think it's clear that really Japan is on the fast track to implementing the automated driving nationwide, at least with a very methodological and also data-driven approach. And I think many of the challenges that you mentioned also for the field tests are something that we are also seeing in Europe with also the harmonization needs and connectivity challenges, the design and transition to level 4. So with that, we go back to Europe and covering even more deeper the deployment aspects with the presentation from Robert Sikora from Omio about their very interesting operational services they are running at the moment in Europe. Robert, the floor is yours.
Thank you very much for the kind introduction. As mentioned before, I would like to focus on operational services from our company. I hope you can see my shared screen. And I will just switch on, which is the area, which are the different areas of use cases we are focusing on. And this is universities and medical centers, areas where long distances have to be taken into account from persons in medical areas that are maybe not so mobile, universities from one place to another place from A to B in a short time. So this is interesting. Another interesting area for use cases are airports, outside the airports, on airside. And everybody can understand that this is very important because the time is also, in most of the cases, an issue. And focusing last but not least on first last mile deployments in cities that allows to tackle the different business cases that are a challenge for public transport agencies or operators. Let me focus on, first of all, mention the different deployments globally. There's 2 of them already existing in Korea, which is Sejong and Sancheon, where our vehicles are driving around in mixed traffic on public sites. Then, just to mention, we already are exploring the possibility to communicate over 5G to avoid the latency issues that are really, well, a burden if you are using 4G or 3G communications and want to do real-time monitoring, real-time control of the vehicle. And last but not least, this is platooning at the JFK airport. I mentioned already airport, a nice market And you see our vehicles speed up to 30 miles per hour in a very low distance, 6 feet, and we can operate then. And the big advantage of platooning is that you can adjust the capacity that can be transported according to the demand. This is our deployment in Luxembourg. Let me go back to Europe, where we have specific challenges for our small shuttles. We have areas like this one where you have nearly no GNSS reception, and localization has to be done in a separate way. We have a limited road width, and you see here parking vehicles, delivery trucks that take away space from the road. We have 2-direction bicycle lanes that take away space off the road. We have here a signalized intersection where we communicate over the air with the red, amber, green light. Many pedestrians and bicycles, depending on there's here a big transport hub, and people want to go from here over to this side where the university is situated. So a lot of challenges, and the track is shown here, different bus stops, and we will focus on that in the next month. The deployment inside an airport, a very good example is Schiphol Airport, where we are working at the moment. You see on the left-hand side the track that brings service employees to the service sites, and they all need to get in a specific it's called door 60. It's the only entry point to get them in, and then they need to be transported to the other areas. And this is also challenging because we have limited GNSS reception, really ultimate safety roads on airside or close to the apron, like here. And all vehicles, not our vehicles, but the other vehicles that are driving around here are driven under time pressure. So the traffic is really challenging. And we have the problem that access to airside is really strictly regulated. On the right-hand side, you see what we are doing as well. It's transporting the crew from the crew center here on the upper right corner, following the blue line, and bringing the crew to the apron where the aircraft is parked and back. So it's another challenging thing because we are moving at least in the first area nearly 600 meters without GPS reception. In Cooperative, this is another deployment in Finland. We have challenges from the winter. It could be up to minus 30 degrees Celsius, where we need to have a special battery management system. We have big snow and ice balls during winter. Then the winter takes away the width of the road. And the crossing of a road, it's here where we have on the crossing road speeds with up to 60 kilometers per hour. So this is more or less what we did and what we are doing in Europe. In the UK, there's further deployment, but this might be another webinar in the future. Thanks for listening, and I hand over to Stefan. Thanks.
Great. Thank you, Robert, for presenting these innovative operational services that Omio is running in Europe. And you mentioned several very promising use cases with the first last mile or also the, shared mobility in specific sites. So with that, I would like to give the floor to our last speaker, Dr. Ismail Zodi, who will speak about the vision and highlights from the Dubai self-driving transport strategy and give us a taste, or at least of what we can see in Dubai when we will be there soon. The floor is yours. Thank you.
Hi, everyone. Thank you for having me. Can you go next, please? Yeah, so as you said, so Dubai has a, I would say, unique strategy. And this presentation will bring different perspective from the previous presentations. We're gonna focus more on how government here tackles the future of mobility, especially autonomous vehicles. So in Dubai, we have a vision to achieve 25% of trips should be in autonomous mode in year 2030. So basically think about it 6 years from now, every 4 people, one of them should be in autonomous mode for every trip. And one of the uniqueness of or specialized thing about the strategy that, first of all, it covers all types of transport, including bus, metro, marine, or the ferries, robots, shuttles, and taxis, and so on. So it's not just only one mode. Some of the cities just maybe have a few trials here and there, but our strategy aims across different modes. Go next. So definitely to achieve this target or this vision, we need to think about different aspects or different modules to fasten the deployment of such technology. So we kind of cascaded into the mode or which partner we should bring to operate in Dubai. We need to make sure that the customer people acceptance are willing to use such technology. Number 3, the infrastructure. So Dubai, I think, is well known about being the top ranked in terms of infrastructure quality. A 4th point, which is the enabling the digital part, the high definition mapping and 5G and so on. Last part is the legislation and policies. So we definitely, those 5 components, this is very simple terms, but they differ from a mode to another. But you can see this is like the common type of tracks we work on. When it comes to the legislation, which is I would say the main role of the government. If you go next, please. Dubai has issued 2 laws related to autonomous mobility. First one is related to trials. So we allow to try autonomous technology in our public roads under this legislation 2019. And another law we issued this year or earlier or last year, sorry. It's about the operation of autonomous vehicles. So I would say the only city in the whole region that already issued 2 legislation to cover both aspects, to give the right environment to companies to try, at the same time to operate for the service. Go next. When it comes to the partnership, one of the things that we are doing here in RTA, which the Dubai government, we partner with the private sector in order to deploy different modes. So this is one of the examples. So we are partnering with the Cruise company, the American company, and the target is to operate a fleet of robotaxis by year 2030, big fleet. But now we already launched last December, which is 6 months ago. We launched the first demo rides to allow passengers to try the service. And the way you can see this picture, this is behind the Burj Khalifa, the famous landmark of Dubai. So this was an indication how government can tackle and I would say attract private companies to operate in Dubai. Go next. So one of the, I would say, different or one of the challenges we had is basically how to localize such technology, right? Because if you partner with a company outside the UAE or not of Emirates, how you can bring this technology and make it sure it's localized to your environmental requirements. So as part of the process that we accommodate here in Dubai, we're trying to do balance technique. So some of the cities that are using more into self-certification, the company provide documents that saying they are or claim they are ready or they are basically are compatible with the requirements. Some other places, cities, they go deep and they bring like third-party review and go through all the processes, all the technology to make sure to give enough permits to operate or trial in their city. Here in Dubai, we try to do something in between, I would say middle ground, because we bring third-party review, but we are more into evaluating the use cases, not the technology itself. So whatever the technology is compatible to do with our environment, we will accept, will not accept. So this was part of the challenges, and we went through with many of the partners. But it was a unique experience to think how we can attract international companies to come to Dubai and deploy and give trials. Go next. Maybe this is my last slide. I can give more examples of the projects we do. We don't only work on the ground, we actually work more higher. So you can see the eVTOLs, and we already launched our agreement, our plan earlier this year, that we will have a flying taxi by year 2026, basically a couple of years from today, with a partnership with our partnership Joby Aviation, along with Skyport for infrastructure design. So this is a nutshell some of the examples we had. I'm more than happy to get questions. And definitely I'll wrap up with my last slide that we are welcoming you in Dubai very soon, almost 2.5 months from today. And definitely you will enjoy more about things we do, and we have more materials, and we'll be more than happy to accommodate you and welcome you again in Dubai. Thank you.
Thank you very much, Ismail. I think you really did show that Dubai is the perfect place to discuss about connected automated mobility drills. And I really particularly like this very ambitious vision that Dubai has for self-driving strategy. So you mentioned considering all the different aspects that I mentioned as really important at the beginning with infrastructure, technology, legislation, and also you're adding this third dimension, which is also very with urban air mobility, which is also very important for Vertico, as we just recently launched a platform on innovative aerial services. So very happy to hear that. Okay, so we have only a few minutes left for questions. I've seen some questions coming in, so it will be difficult to address everything, but I see at least a common denominator, at least to many of the questions which are really related to how we can make this happen, actually really considering all these different components and the challenges. So I would just like to give the floor a bit to each of you to maybe quickly in a minute or two to give your views. So let's maybe start with Max. So you mentioned the compromise, the need to compromise, and the different elements of the puzzle. So how will the puzzle come together in order really to make the autonomous vehicle happen in your view?
Yeah, thanks, Stefan. I think the most important thing is we have to really work together here. And the different actors with different roles. If we all go individually, it will not work. So we have to get our act together. And in Europe, that means we need a coordinated approach with industry in the lead. We clearly see industry with their innovation as leaders here. So we need to work across industrial actors. That also means across competitors in a pre-competitive way. We have this notion of non-differentiating elements, because some of what an autonomous car everybody has and the driver doesn't and the owner doesn't see. So that's non-differentiating. We also need to work across national and EU partnerships in Europe and across the many member states in Europe. The big issue for Europe to have a common market. I think it's also important to have close collaboration between innovators and regulators. We need an innovation-friendly regulatory framework with safety and security first. I've said that before, but it's worth repeating. And last not least, something that also some of the colleagues were mentioning, I think it's needed that we do more piloting, but piloting not only in the tech sense, not tech pilots only, but we also need piloting with the regulation. So we often call that regulatory sandboxes that allow us to do certain pilots in a regulatory environment, which is probably a bit relaxed from the normal regulatory environment. And we see that popping up across the world, but we probably need to reinforce that. So that would be my summary of how I see to support the rollout, the deployment of automated towards autonomous driving.
Thank you, Max. Yeah, I fully agree. I think this cooperation is really essential. I mean, we have seen that definitely we need it in Europe to align, but I think it's important as well internationally. What I see is that the different regions have different approaches, different policy approaches, different learnings that we can benefit from that actually to avoid repeating mistakes and also share our best practices. Well, that's really great. So let's go then to Steve. So Steve, you mentioned more specifically indeed challenges so related to artificial intelligence and others. So how do you think that this can? So is this really? I mean, like AI, for example, can it be really malicious? Should we be concerned about this? And how should we actually regulate or address this in your view?
Well, kind of teeing off what Max said, I think one of the things that Ertico is doing that's fantastic is pushing the whole concept of connected. In the U.S., most of the solutions that you read about have no connector and no cooperative aspect. In other words, the vendors are doing their own independent system, and they are not communicating over the infrastructure with other companies. You know, they may do within the company, but they don't do outside the company. And I think that leads us up to this. We've got to find a way to get more open data out of automated systems and learn from other mistakes. In the U.S., we simply, I think, are way too myopic with just allowing vendors to do it. The other aspect that you alluded to with the question is that there's downsides to AI, and we probably need to be starting to take a look at that. There's malicious things that can be done with artificial intelligence, whether intentional or not, in mistakes. And I think there's a whole area of information sharing that could be helped out by regulation and pushing by organizations like Ertico.
Thank you. Yeah, indeed. I think that's really a very important aspect. As a multi-stakeholder partnership, it's important that we bring all these stakeholders together to solve this kind of challenges exactly related to data and connectivity in particular, you know, as we will have to have hybrid connectivity available. Okay, thank you. Then to Shirato-san. So I mean, as we spoke about collaboration, and I think you mentioned as well now the path towards level 4 and so on. So I'm wondering here on how there's a collaboration with the car manufacturers in particular in order to move forward towards the level 4 at the moment in Japan.
Okay, yeah. Okay, so I've introduced about some 3 major OEMs. And the one is the Toyotas, and you may know that the Toyota has developed the named e-Pilot, the autonomous electric vehicle, since 2020. So they still have been testing in many areas to develop the more safe and reliable systems. And the Nissan has just commenced the demonstration of the prototype vehicle equipped with its in-house developed autonomous drive technologies, and demonstration in Yokohama this month. And Honda is working with the Cruise to develop the self-driving commuters. So they believe that there is some driverless hard-haul services like the Uber taxi, such become a new mobility option for more people. So I think that those car manufacturers are mainly focusing on some driver assistance systems, but also aims to develop the cars for the level 4 automated driving, and for dedicating for some public transportation services. So the inferiors, maybe some car manufacturers are joined to such kind of level 4 automation technologies field. I think, yes, that's all.
Yeah, indeed. I think these are definitely challenges, but yeah, I think you are very interesting developments to make this happen, what I see. So let's then quickly go to our next one, which is Robert. Who is Robert? So from your side, I mean, you have been really looking into more operational use cases. So what do you see then from the learnings? What are your main learnings actually on the barriers that need to be overcome here in these particular services that you have been deployed here?
Thank you for mentioning that. I do believe that it was addressed from many sides today. We need to do something in Europe for regulation, and this has to be harmonized, and we have to work together in the different member states of Europe to make it happen. This is one of the legal burdens that we have, and well, in addition, I think we have to mention that 2 aspects. First, we don't do that to get rid of people. We have a lack of drivers, and that's the reason why we address this. And the second aspect, it's at least from our perspective, an important way to address the shared mobility issues. You won't ease the pain that we have from congestion with switching from a passenger car to an autonomous passenger car. So that's the reason why we are, with our shuttles, focusing on public transport, shared transport, and this is the reason. And in this area, we also have burdens because the public transport operators need to be convinced that this is a way forward for their business cases. But we are working on that. Thanks.
Yes, thank you, Robert. I think, yeah, indeed, the question on the regulation is something that we addressed with a strong input from your side, indeed, in the high-level dialogue that we had a few weeks ago. So, so definitely good, I think, on a good path, but still a lot to do there. Okay, so then before I would like to give the floor to our last speaker as well, for Dr. Ismail. So you mentioned indeed the ambitious strategy there, which. But what makes it really unique, you think, compared to the other cities, and what can you learn as well from that in order to give us any recommendations on the path towards deployment?
Yeah, I think we are running out of time, so I can say just one word, that definitely Dubai has a unique strategy, and it's one of the the few strategies that tackle different modes. And the way that we do partnership, attract companies, we conduct, let's say, Dubai World Challenge for competition to ask all the different stakeholders to come to Dubai and show us the best technology, and which can be accommodated by us in Dubai. Anyway, come to Dubai for the ITS Congress. You'll learn more about what we do. You'll see by yourself, and definitely be among all of us to discuss how we can collaborate in the future. Thank you so much.
Thank you, Ismail, for this. Indeed, there's still many questions coming in, but I think the best place to discuss this further is to come to Dubai and talk with all of us there. So thank you very much to all the speakers. So I just let Rita close this webinar. Thank you very much from my side. Thanks.
Thank you, Stefan, and thank you so much to all our panelists and our audience today. As you can see, it is a topic, CCAM, more than the sum of its parts. There's a lot to learn, to see, to explore, and we've touched on it a little bit. I'll just echo the sentiment here. Come to Dubai, follow us on our channels, on our social media, newsletter, etc., to keep in touch. And I'm very sorry, I know there are some more questions, but we've run out of time. Do get in touch with the speakers through email or reach out to us at Ertico, and we will try to get you answers. Thank you, and hope to see most of you in Dubai. Bye-bye.